Hi everyone, myself Dr. Antara Mohanto Borua. I am working as an assistant professor in the discipline of electronics at Krishnakanta Handike State Open University. Today we are going to start the course. Today I have here for the lecture 1 of domestic equipment maintenance. Different types of domestic equipment would be highlighted in this course. As far as the course objective is concerned, this course would enable the learners to identify the common tools with specifications and functions used in maintenance of household electric equipment. To understand the working principle, steps of operation and maintenance of various domestic equipment. Also, this course would enable the learners to familiar with common faults and troubleshooting processes of domestic equipment. Whatever you gain out of this course may be useful for identifying the defects and their troubleshoot that arises in the equipment. Before starting the first topic, let us take a quick look in the course structure. The course would be covered in 15 modules. The course structure goes like this. In the first week, one module having 3 video lectures. First is on understanding electricity. Second lecture would be on electrical energy and its conversion. And the third lecture would be on basic safety practice. The 2 modules of second week having 3 lectures. The first is on tools and equipment used for handling household appliances. Second and third lecture of third module would be on some electric appliances that are based on electric thermal effect. The second part of the third module will be continued in the third week having 3 lectures on some kitchen appliances such as automatic rice cooker, electric kettle, induction cooker, toaster, etc. The fourth module of fourth week having 3 lectures. The first lecture is on mixer and grinder, and the other 2 lectures are on basics and working of washing machine and its operation and maintenance. In the fifth week, the module will be highlighted on construction, operation and maintenance of microwave oven and water purifier having 4 lectures. The 6th module of 6th week would be on basics of inverter and geyser, which have 4 lectures. In the 7th week, the module would be on vacuum cleaner having 2 lectures. And in the 8th week, there will be 1 module having 3 lectures on refrigerator. In the 9th week, the 2 modules would be on cooling equipment and power supply. First 2 lectures are on construction and working principle, operation and maintenance of air conditioner. Next lecture would be on basics and working of power supply. The 10th week will be exposed to 2 modules on audio equipment and video equipment basics. And the first module having 2 lectures and the second module having 3 lectures. The module of 11th week will be on cell phone and digital camera, and it will be covered by 3 lectures on basics, working, principles and maintenance of mobile phone and digital camera. In the last week, that is 12th week, having 2 modules of 4 lectures, which will be highlighted on home security system and computer system and its peripherals. This is all about the course layout. Now we shall start the first topic. Our first topic is in understanding electricity. In this module, first we will introduce you to the basic concept of electricity. Here we will discuss how electricity, electric charge, current, voltage and power originates and what are their properties. If you are from science background, then you will be comfortable with these terminologies and the units of electricity. However, since this course is common to all students who are willing to learn domestic equipment, operations and maintenance, we are going to review about the terms related to electricity. Now, the contents of this topic are electron theory, electricity and electric charge, types of electricity, then sources of electricity, and then electricity generation, transmission and distribution. We will also highlight the types of electricity, sources of electricity, and then an attempt is made to explain electricity generation, distribution, transmission in the first topic of this module. So let us first discuss what is electron theory. The electron theory is the fundamental concept in physics that explains the behavior and properties of metals in terms of the movement of electrons. For understanding the basic concept of electricity and electric charge, we must know the electron theory. According to electron theory, metals are the primary made up of electrons as charge carriers. Before explaining the electron theory, it is important to understand the few things. These are mainly matter, what is molecule, and what is atom. First, matter. Anything that occupies space and has mass is called matter. It refers to the physical substances and materials that make up the universe. Matter can exist in various forms, including solid, liquid, gas and plasma, depending on the arrangement and behavior of its constituent particles. Matter is composed of atoms and molecules. So what is molecule? If you go on breaking any matter to smaller and smaller parts, a stage will come when it becomes unbreakable. This the smallest size that a matter can occupy, where all the properties of the matter is preserved. If you try to break it further, it will lose all its properties. This smallest size that occupies the complete set of properties of a matter is known as molecules. Some examples of molecules are oxygen gas, water, carbon dioxide, etc. Every matter, both living and non-living, is made from the combination of such molecules. Atom. If molecules are further divided into smaller parts, become available, which are known as atom. But the atoms cannot exist independently. The only exception to it is that when a molecule is made up of only one atom, the properties of an individual atom are totally different to that of the matter. According to the electron theory, all the matters are made of such atoms, and these atoms consist of three fundamental elements. They are proton, neutron, and electron. The central part of an atom is known as nucleus. It almost contains all the mass of the whole atom. The nucleus consists of proton and neutron. Protons are positively charged and neutrons are neutral, that is, they possess no charge. So, the nucleus is always positively charged. The electrons move around the nucleus of an atom in some orbits that are negatively charged particles. In metal, some of the outermost electrons are loosely bound and can move freely throughout the metal structure. The positive charge of an proton is equivalent to the negative charge of an electron. So, in an atom, the number of protons and electrons are same. The number of electrons and protons depends on the matter and is different for different matter. It is the structure of a hydrogen atom. In hydrogen atom, it contains one electron and one proton, whereas in case of carbon atom, it contains 6 protons in its nucleus and 6 electrons move around it in 2 orbits, 2 electrons in the inner orbit and 4 in the outer orbit. The maximum number of electrons that the orbits follows by using this mathematical formula. E equal to 2n square. where n is the count of the orbit and e is the maximum number of electrons that the orbit can have. This means that for the first orbit n equal to 1, so e, that is the maximum number of electrons in that orbit, it will be 2. So it cannot have more than 2 electrons. Similarly, the second orbit can have the maximum number of 8 electrons. The third one can have 18 electrons, and so on. When the number of electrons and protons are same, then they neutralize each other's charge, so as a whole the atom is neutral. If the case is such that the outermost orbit of the atom contains more electrons than the fixed value, then the atom is called negatively charged. And if the number of electron is less in the outermost orbits than the maximum value, then the atom is called as a positively charged. Now let us move to the next topic, that is electricity and electric charge. When there is an imbalance of electrons and protons in an object, it becomes electrically charged. There are a few ways in which objects can become charged. So first one is the friction. When two objects rub against each other, electrons can be transferred from one object to another. The object that gains electrons becomes negatively charged, while the object that loses electrons becomes positively charged. For example, rubbing a comb against a woolen cloth or dry hair can transfer electrons and charge the comb, and it can attract small pieces of paper. Next is conduction. Electric charge can also be transferred through direct contact between two objects. If charged object comes into contact with a neutral object, some of the charges can be transferred, resulting in both objects acquiring the same charge. For example, touching a negatively charged object to a neutral metal object can transfer electrons and charge the metal object. Next way is the induction. Induction means the redistribution of charges in an object without direct contact. When a charged object is brought close to a neutral object, the charges in the neutral object can be rearranged. For example, if a negatively charged object is brought near a neutral object, electrons in the neutral object are repelled and move away, leaving the side of the object closer to the negatively charged object positively charged, and the side of the farthest from the charged object leaving negatively charged. It is important to highlight that objects can acquire charges of either positive or negative polarity depending on the movement of electrons, and this phenomenon of getting charge is called electricity. When two similar charges come closer, they repel, and when two charges of opposite nature come closer, they attract each other. The unit of charge is known as coulomb. The electrons in the outermost orbits are known as valence electrons. In an atom, attraction of nucleus to the outermost orbit is poor. Sometimes they get detached from the atom. These electrons are now free to move from one end to another. This flow of free electrons is also termed as electricity. Now let us see in this diagram. If a conductor is connected to the battery terminal, then the free electrons in the conductor flows towards the positive terminal, and the current flows from the positive terminal towards the negative terminal. The direction of electron flow and current flow in the conductor are in opposite direction. Electric current is the flow of electric charge over time. It is typically measured in amperes and represents the rate at which charges move. Mathematically, it is expressed as C equal to Q by T, where Q represents the charge, is measured in coulomb, and T represents time and is measured in second. It means coulomb per second is the current and is termed as ampere. So the unit of current is ampere. Electric potential and voltage. Electric potential and voltage describe the behavior and characteristics of electric field and the movement of electric charges. Whenever a body is to be charged, some work has to be done for charging it, and this work done is stored in the body in the form of potential energy. In the next lecture, we shall discuss the energy in details. Now, the charged body is capable of doing some work in the form of moving another charged body by attraction or repulsion. This capacity to do work of a charged body is known as electric potential. In simpler manner, the electric potential can be defined as the work done of charging a body to a unit charge. Mathematically, electric potential V equal to W by Q, where W is the amount of work done and is measured in joules, and Q is the charge measured in coulomb. So the unit of electric potential is joule per coulomb and it is termed as volt. Now, voltage, also termed as potential difference, is a measure of electric potential energy difference between of two charged bodies. Let us see this example. If two charged bodies have different potentials, then they are said to have potential difference. For example, let us take two charged bodies A and B having different potentials, and the potential of B is higher than A. If these two bodies are connected together, free electrons from A will flow to B. This occurs as because B is at higher potential, and as the definition of electric potential shows, charge is inversely proportional to potential. This signifies that B is at higher potential, so its charge is less. That is, the free electrons from A will rush towards B. It means that a current flow will occur between these two bodies whose direction is opposite to that of the electron flow. This current will retain till the potential of these two bodies become equivalent. So, whenever there is a difference in potential at two ends of a conductor, the electric current flow will occur in the conductor. As the unit of potential is volt, so the unit of potential difference or voltage will also be same, that is volt. Both electric potential and voltage are the fundamental concept in electrical circuit and determine the behavior of electric charges. Power. Generally, the rate at which work is done is known as power. It can also be defined as the work done per unit time. As the unit of work done is joule, so the unit of power is joule per second, and this unit is known as watt. In case of electrical system, whenever voltage is applied across a conductor, current flow starts because of the movement of electrons. During this process of movement, the electrons collide with the atoms of the conductor, and in this process of collision, heat is produced. This heat produced totally depends on both the applied voltage and the current. It is produced as work has to be done to overcome friction due to electron movement. This work done per unit time is power, and it is always equal to the product of current and voltage of a particular circuit. Mathematically, we can express power as power equal to voltage into current. Types of electricity. Electricity can exist in different forms such as direct current, alternating current, static current, and dynamic current. So what is direct current? In a direct current, the flow of electric charge is unidirectional, meaning the charges move in one constant directions. Direct current is commonly used in batteries, electronic devices, and certain industries or applications where a steady current is required. It is generated by sources such as battery, solar cells, or rectifiers. Whenever a circuit having a conductor and a load is connected to a voltage source, the current flow starts through the conductor. And if the voltage source is a battery having a positive and negative pole, then the current will flow in a single directions until and unless a potential difference exists between the two battery terminals. Now, what is alternating current or AC? Alternating current periodically changes its direction, means the charges oscillate back and forth. AC is the common type of electricity generated by power plants and supplied to homes and industries. It is generated by alternating voltage sources and has a sinusoidal waveform. The standard frequency of AC power in most countries is 50 or 60 Hz. Static electricity. Static electricity refers to an accumulation of electric charges on an object, typically generated through friction, contact, and induction. It is characterized by the buildup of charges that do not flow as an electric current but can produce static discharge like spark or shocks. Dynamic electricity. Dynamic electricity refers to the flow or movement of electric charges in a conductor. It involves the continuous movement of charged particles, typically electrons, through a closed circuit. In simpler terms, whenever electricity is produced due to free moving electrons, it is called dynamic electricity. All the electric appliances around us run due to this dynamic electricity. All these types of electricity have different characteristics, applications, and generation methods. Now, sources of electricity. There are various sources of electricity that are used to generate the electrical power. All these sources are available in the nature. These sources can be classified into two main categories. These are conventional or non-renewable sources and non-conventional or renewable sources. Conventional or non-renewable sources of electricity. Fossil fuels, coal, oil, and natural gas are sources of electricity known as fossil fuel. These fuels are burned in power plants to produce heat, which is then used to generate steam to drive turbines connected to the generator. Another conventional source of electricity is nuclear fuel. Nuclear fuel is also used for production of electricity. Nuclear power plants generate electricity through nuclear fission, where the nucleus of an atom is split, releasing a large amount of energy. This energy is used to heat water and produce steam, which drives the turbine to generate electricity. Now, non-conventional or renewable sources. Non-conventional or renewable sources of electricity are those that are naturally replenished and have a minimum impact on the environment compared to the conventional sources. These sources do not produce greenhouse gases. Replenishment rate of renewable sources is higher than they are consumed. Example of few renewable sources of electricity are solar power. So solar energy is obtained from the sun's radiation. Photovoltaic cells or solar panel convert sunlight directly into electricity through the photovoltaic effect. Next is wind power. Wind turbines convert the kinetic energy of the wind into electrical energy. As the wind blows, it turns the blades of the turbine, which then spin a generator to produce electricity. Next, hydropower. Hydropower uses the energy of flowing or falling water to generate electricity. It involves building dams across rivers to create reservoirs. The water released from the reservoir flows through turbines, generating electricity. Hydropower is a permanent renewable source of electricity and is commonly used worldwide. Geothermal energy. Geothermal power utilizes heat from within the earth. Geothermal power plants use steam or hot water from underground to drive turbines and generate electricity. Geothermal energy is particularly abundant in areas with volcanic activity. Biomass energy. The biomass refers to organic materials such as wood, agriculture residues, dedicated energy crops, and organic waste. Biomass can be burned directly to produce heat or converted into biogas or biofuels to generate electricity in biomass power plant. The next renewable source of electricity is the tidal power. Tidal power utilizes the energy received from the rise and fall of ocean tides. Tidal barrages or tidal stream generator use the movement of water to rotate the turbines and generating electricity. Tidal power is location specific and requires suitable coastal conditions. The next renewable source of electricity is the wave power. Wave power captures the energy from ocean waves. Various technologies such as floating devices, oscillating water columns, or submerged turbines are used to convert wave motion into electricity. These renewable sources of electricity provide a sustainable energy compared to conventional fossil fuel based power generation. Their adoption is essential in reducing greenhouse effect, preventing climate change, and promoting a more sustainable energy future. The next topic is the electricity generation, transmission, and distribution. Electricity can be generated, transmitted, and distributed for various purposes. Electricity plays an essential part in our lives and almost all appliances need it. Electricity generation, transmission, and distribution are the key components of electric power system. The electric power system, also known as electrical power grid, is an interconnected network of power generation, transmission, and distribution system. The function of a power grid is to distribute electricity to consumers in efficient and low-cost mode. In the power grid system, electrical energy is generated in centralized power plants and transported over a long-distance transmission and distribution networks before reaching the end consumers for power consumption. The four sections consist in the electric power grid system are power plant section, which is used for energy generation. Next is transmission section for energy transmission through transmission lines. Next is distribution section for changing voltage level at the distribution substation, and the power consumption section by various consumers. The power plant section, electricity is generated in the power plant using various sources of energy such as renewable and non-renewable sources. Transmission section, after electricity is generated, electric utilities transmit it over a long distance through high voltage transmission lines. These high voltage transmission lines carry the electricity from power plants to distribution substations. Next is distribution section. Electric utilities distribute electricity from the transmission network to consumers through a system of low voltage distribution lines. Distribution networks consist of transformer, substation, and power lines that deliver electricity amongst the various customers. In general, the customer types are of three types: residential, commercial, and industrial. In practical terms, voltage is associated with the electrical power supply in our homes, where the voltage is standardized to 120 volt or 220 volt depending on the country. Now, in the summary, we have learned in this topic are the electron theory, electricity and electric charge, types of electricity which includes direct and alternating current, static and dynamic electricity. Next, what are the sources of electricity? We have got two categories of sources of electricity. One is conventional and the other is non-conventional. And the last part, electricity generation, transmission and distribution. So this is all about the topic on understanding electricity. Here are some questions related to this session, like how does an object become electrically charged, why the direction of current is opposite to the direction of flow of electrons, define electric potential and electrical power, mention their SI units, what is meant by the potential difference between 2 points, what is the difference between DC and AC electricity, identify some common sources of each type of electricity, then define the static and dynamic electricity, what are the conventional sources of electricity, then what is the difference between conventional and non-conventional energy sources, what is a power system, mention the three basic components of power system, then what is the difference between the transmission line and distribution line. So learners, if you have any doubt or queries regarding the contents or a specific topic of this particular module, you can directly contact us through email, and we are always here to help you and provide you all the support during this particular course. In the next topic, we shall discuss about electrical energy and its conversion. Thank you very much.